I mentioned there are 6 hyperbolic trig functions, and you could probably guess what the other ones are. We're just going to borrow from the regular trig functions. So we're going to have y equals sech x, and that is how you say that, sech of x. That's the hyperbolic secant. And I can define that as the reciprocal of cosh of x, or I could define it in terms of the exponential function by actually flipping that fraction and saying that's 2 over e to the x plus e to the negative x. Now, I am going to hold you responsible for being able to work with any of the 6 hyperbolic trig functions. I mentioned I'm only going to hold you responsible for being familiar with these 3 graphs. That's because if you know those, you can really figure out what the graphs of their inverses look like. So I'm actually just going to very quickly sketch them just to review how we can use a graph to figure out the graph of the reciprocal. Cosh is always positive, so its reciprocal is also always positive. Sech will also be always positive. Okay, and the low point of cosh has a y value of 1. The reciprocal of 1 is 1. So 0, 1 will be on the graph of sech, but it's going to be a high point. Okay. Cosh is symmetric about the y-axis, so its reciprocal will be as well. Let's just get the right side first. Cosh is increasing, so its reciprocal will be decreasing. And the bigger cosh gets, the smaller its reciprocal gets. If cosh is going off to infinity, sech is going to go off to 0. But it's got to stay positive because the reciprocal of a positive is positive. So sech is going to look something like that. Okay. Then we've got y equals cosech of x. We can define that as the reciprocal of sinh. And of course, if we want to write that in terms of the exponential function, that just means it's 2 over e to the x minus e to the negative x. Now, if I were to graph that, I can see it's not going to be defined at 0 because I can't take the reciprocal of 0. But this part of the graph of sinh was in quadrant 1, so it's got positive y values. The reciprocal there is going to be positive. And you'll notice the y values go from very small, close to 0, to very big. They go off to infinity. We're going to just reverse that process when we take the reciprocal. So it'll look something like so. Over here, we've got negative values, so the reciprocal will be negative. Here we're going from very, very big to very, very small, close to 0. Again, when we take the reciprocal, we just flip that relationship. So we get something like so. Okay. And then we can define y equals cotan of x. You are going to need to be careful going forward that you read problems carefully. You can expect that in this particular section, a lot of the functions are going to be hyperbolic trig. But now you've got to look carefully to see, is there an h in the name? Are you working with the hyperbolic trig function or the regular trig function? Cotan can be defined as cosh of x over sinh of x, or as the reciprocal of tan of x. And those are equivalent here, because both are undefined if x is equal to 0. Okay. All right. So if I look here, like I said, it's going to be undefined. Oh, and I'm sorry. I can also then write it in terms of the exponential function. So that would be e to the x plus e to the negative x over e to the x minus e to the negative x. Okay. If I were to look at the graph, as I said, it's going to be undefined at 0. I can see here that tan is positive. The reciprocal of something positive is positive. Okay. We start out close to 0, so the reciprocal is going to start out really, really big, going off to infinity. We end up close to 1, and the reciprocal of 1 is 1. So we're going to start big and come down. We'll have a horizontal asymptote at 1. We're just approaching it from above instead of from below. And then on the left side, cotan is negative, so its reciprocal will be negative. We start out close to -1, and the reciprocal of -1 is -1. So we'll start out close to -1. Here we're approaching 0, so the reciprocal is going to be going off towards negative infinity. Don't have a lot of room here. Okay, so No need to spend an awful lot of time studying those graphs, but I hope that you're familiar with the process by which we generated them, because that's a useful skill to have. What I'm going to have you do in the next video is evaluate some hyperbolic trig functions at various numbers. And I'm going to erase the board before I do that. So make sure you've got written down these formulas. You could say, oh, I'll just look them up in the book, but I think it's actually helpful to write them down, because as you write them down, it's going to help you to remember them. Really, you need to know these two definitions. If you know these two definitions, you can get all of the others, because we're just borrowing from the relationships that our trig functions have and letting the hyperbolic trig functions inherit those relationships.